So did you get this table?
Yeah.
Yeah, we got that.
Take as well?
Yeah.
Okay. So working modulo n is like wearing special glasses that convert each number into its remainder modulo n. So for example, to compute the following sum modulo 12, so to find the remainder modulo 12, what you do is you put your glasses and then 19 becomes 7, 23 becomes 11, and 15 becomes 3. Then you do 7 plus 11 plus 3. Well, 7 plus 3 is 10, and then the sum is 21. And then you convert that into the remainder modulo 12, which is 9. Okay? So the answer to this question is we need to because we're talking about days of the week, we are working modulo 7, and we need a remainder of 1,000 when divided by 7. The best way to do that is to subtract a multiple of 7 from 1,000. So tell me a big multiple of 7 that is not too far from 1,000. An easy one.
700.
700. So 1,000 minus 700 is 300. So 1,000 is the same as 300. Now tell me a multiple of 7 that is close to 300. That something that is easy to see that is a multiple of 7.
280.
Exactly. So then you decompose 300 into 280 and 20. Then a multiple of 7 close to 20. I mean, but lower than 20.
14.
14. So given that then when you put your glasses, all these multiple 7 becomes 0. So 1,000 is the same as 6. Okay. And then in 6 days it's easy. I mean, if today is Sunday, in 6 days will be Saturday. Okay. So in 1,000 days will be Saturday. Okay. So now I would like you to practice this. These 3. So, well, let's go in order. Sophie, the remainder of 31 modulo 3.
1.
Take, the remainder of 44 modulo 3.
2.
And
No.
Nicole, the remainder of 75.
0.
0. Any of you, the remainder of 7,501. Okay. The important thing is you don't need to do the division. I mean, you just do this trick of the remainders. Okay. Sophie, the first one. This is modulo 2.
Okay.
The first one is
0.
this is even and this is
No.
odd.
Sorry, it's 1.
Okay. Take, the second.
1 minus 0, which is 1.
Yeah. Okay, Nicole, I promise Nicole that next time I'm going to do in another order because you are getting always the hardest. So this is what modulo 12? The first number.
75.
No, modulo 2, sorry.
Oh, 1 second.
So modulo 2 is either 0 or 1, depending if it's even or odd.
Oh, 1.
So this one is 1, this one is
2. 0, sorry,
0, and this one is
1.
so you get 1 minus 0 plus 1, which
So,
is 2,
1.
which is 0. Okay?
Yeah.
Okay. Well, I volunteer for the first one.
Sure.
Take. Okay.
The first one, it's 7 plus 4, which is 11, plus 7, which is 18, which is 6, plus 30, which is 0.
Oh, 30 is not multiple of 12.
Anyway, 30 plus 6 will equal 0.
Well, to be you were doing like the cumulative converting. I think, well, 24 is multiple of 12. So I would have said this is 7, this is 4, this is 7, and this is 6. So 7, 4, 7, 6. Well, I would have write it down with a pencil or a pen. No? 7, 4, 7, 6 is 7 and 7, 14, and 4, 18, and 6, 24. You end up with a multiple of 12. So this is 0. Nicole, what about this one?
The first one is 2.
Yes, because it's 36 is multiple of 12. Yes, so this is 2 times, well, 4 is lower than 12, so you don't convert it. So
Okay, so it stays as 4.
2 times 4,
8.
and then what about this one?
30. So that would be remainder of 6.
But is this a multiple of 12, or what is the remainder of this one when you divide it?
0.
0. So this one is 0 modulo 12, and here you get 2 times 4, so 2 times 4 is 8. That's all. Sophie, the last one,
6.
because 60 is multiple of 12.
There's a remainder.
Yeah, so 6
Yeah.
plus 5,
There's 60. Yeah.
6 plus
Oh,
5,
6 plus 5 plus 2 was 13. So then you get the remainder of 1.
correct. Okay. Let's go back here. Sorry. Okay. What can we represent with modulo 4? So we have
Seasons?
seen modulo 2, modulo 3. With modulo 4, what?
Seasons?
Yeah, the standard seasons. No, I mean, arbitrarily, we assign one of the seasons to 0, and then we get the rest. Okay. And by now you're realizing, I mean, the pattern. No, 0 is the multiples of 4, 1 is multiples of 4 plus 1, 2 is multiples of 4 plus 2, and 3 is multiples of 4 plus 3. So modulo 4, 4 is the same as 0, minus 2 is 2, 13 is 1. And okay, Take, the first row here.
First row 0, 1, 2, 3.
Nicole, the second one.
0, sorry. 1, 2, and 0.
1, 2,
3.
this one, 3, and the last one, 0. Sophie, the next row.
2, 3, 0, 1.
And Take, the last one.
3, 0, 1, 2.
Yeah, sorry, what happened here? Okay, sorry, I got my mistake, I went back. So yes, that's the table. Okay, and I realize I don't have the. Could you tell me the multiplication table? Well, or could you practice, sorry, on your own, the multiplication table? Okay, I'm going to stop here. Yeah, could you try the multiplication table, modulo 4?